Hello guys, this is Sham from BreVITy, and today we're going to be solving the bar and steady gene problem. We'll be solving this problem using the two-pointer approach to solve it efficiently. So before we get started with that one, let's look at a more common problem and solve it with the two-pointer approach, and based on that, we'll solve this one. Okay, so this is a minimum window substring problem. In this, we're given two strings here. This is string 1, this is string 2. And we basically have to find out the length of the smallest substring in this string, which contains all the characters present in the second one. So for this, we start with two pointers. Let's call them I and j. And they initially point at the first character. And now C is actually present here, so we mark that and we go to the next one. O isn't present, so we can go to the next one. D isn't, E also isn't present, and we reach B. Now we know that B is present in the second string, so we mark that and we go to the next character. Now A is also present here, and we see that we found all of the characters. So now we note the length here. So our j pointer is over here and I is at the start. So we can calculate the length and we see that it's 6. So then we store it here. After which we try pushing it from the left side using pointer I. But we see that as soon as you move this to the next one, you lose C. And if you lose C, you don't have all the characters. So basically that's not valuable. So we continue with j and we go to the next one here. N, it isn't present, and when we reach here we see that we have two C's actually. So now we can go back to our I pointer and we can move it forward, because even if we lose this C over here, we still have another C, and so we have one C here and we still have all the characters. So we again take the length. Right now I is over here and j is here. So the length is actually increased here, so we don't store it. And then we try moving the I pointer again, D, and D isn't present, so we can leave it. We can go forward again. E, it's not present, so it doesn't matter. And we reach here. So this is as far as we can go, because if we go beyond this, we lose B, and we won't have all the characters required. So from here we calculate the length. So it's from here till here, and we see that the length is 4. It is decreased. And now once again we carry on with the j pointer. And we reach this one, D isn't present, and after which we go to the string. So this is where we stop. So this is how you use the two-pointer approach to find out the length of the smallest string in substring in this string, which contains all the characters present in the second one. Now let's look at the bar and steady gene problem. So in this problem, we're given a gene which is basically a string, and this string can contain 4 characters, A, C, G and T. And also the length of the string is always divisible by 4. So you can split it into 4 parts. In this case, we see that the length of the string is 8 and n by 4 is 2. So the condition which makes any given gene a steady gene is that the frequency of each character has to be exactly n by 2. In this case, we see that there are 2 A's, 2 T's, 2 C's and 2 G's. So we can say that this string is steady. Let's look at this one. We have 4 A's here, so we clearly see that it's not steady. We have 1 C, 1 T over here and 2 G's. So if you just try solving it manually, you see that one of the solutions here is to replace this. And that's exactly what you have to do in this problem. You'll be given a string and you have to find out the smallest substring which upon replacing can make this entire string steady. So here you can replace it with something like CT, which will decrease the occurrence of A to 2 and will also increase the occurrence of C and T here. So once again we use the 2-pointer approach here, and the difference here is that we have one pointer starting from the beginning, it's I, and the other pointer starts from the end. So the reason we're doing this is, let's go back to this one. Here we actually have to find out the substring which satisfies the condition, which is basically that it contains all the characters here. And you can just exclude the ones on the left and the right. We basically need only a string here which satisfies the condition. And in this case, we're trying to find out the substring which doesn't satisfy the condition. So if you look at the one on the left and the one on the right, they actually satisfy the condition. They have the occurrence of all those 4 characters less than n by 4 or equal to it. And in this case, we'll use these pointers here, and ideally what you'll have to reach is get to a point where I can actually start from here, include all these characters up to here. Because after that, when you try to include this one, you see that the occurrence will actually be 3. Because we already had 2 A's here, and if you include this, that'll be 3, and that'll be a violation. In the same way, we have this pointer, J pointer over here, and when you try to bring it here, you'll have to include A, that once again increase it. So that's basically how we try to solve it. Let's look at another example. So it's the same one, and let's go through this procedure completely. So we have I and J pointers here. Let's start with the J pointer. We first include this character. So that's 1G. We go to the next one. So now we have 1A. We go to the next one again, and now we have 2 A's here. And you see that you can't go beyond this because including this would make it 3. And in this case, again, n is 8 and n by 4 is 2. So you can't exceed 2. So now in this case, we stop here and we basically note down the length. Because it's true that if you replace this entire string over here, the entire substring, this string can become steady. So that's one of the cases. And the length here is 5. And we start including all the characters from the left end. The first one is A here, and as you can see, if you include this, it will increase to 3, which is a violation. So we first move the J pointer to the right. We move it here, and as you can see, the count is decreased to 1, and then we include this, so now it's back to 2. And this is one more valid condition. And because you moved the J pointer as well as the I pointer, the count should remain the same. In this case, we move it again. Now we have 1C. This still satisfies the condition, so you can note down the length here. And it has decreased to 4. You can move the other pointer now. You have 1T and it has decreased to 3 now. And you can include this too, because now you have 2 G's, which is fine. And now you see that the length is decreased to 2. Basically only have 2 A's now. After this, obviously you can't go to the next one and increase, because including this would increase the count to more than n by 4. So we start moving from this end. We move our J pointer to G here, so we again decrease the count, and once again if you include this, it will increase it and it's still 2. So this is one more case here, and the length is still 2, which is the minimum one, so it doesn't matter. And then when we move it, it goes outside the string. So this is basically our terminating condition, and you've seen that we were able to identify that the minimum length of the string which you have to replace is 2. Now let's look at another example here. In this case, you can clearly see that there are excess number of A's and it's not steady. So once again, let's follow the same procedure. We have a j pointer here, and you can safely traverse till here because you'll have two ways and you can't include the next one obviously. And you have the ith pointer here, so you basically initially set the length to 6 here, and then we try moving this. We include g and it's fine. It has decreased to 5 here, and when we try to move it across, we have to include this a, and that will increase it to 3. So we try pushing j to this one and we include this. So the count will again remain as 2, and since we pushed both the pointers, the length also remains 5. And the next one is you have to include this. So for that you'll have to push it and it goes outside. So, and you can see that the count will still remain the same because we pushed both pointers. And because j has gone outside the string, this is basically a terminating condition, and the minimum length in this case was 5. So now that we have a good understanding of how to solve it, let's look at the code. Okay, so this is a function which we have to complete. Takes in the g, which is string, as the input, and it has to return the length of the smallest substring which we have to replace in order to make it steady. So for this, we first need a data structure which can basically hold all the counts of each character. And so we have a map here which maps the character to the frequency. And then we need a variable to hold the length of g. And then we have two pointers here, the first one starting to the beginning and the next one to the end. So we first start moving the j pointer, and we have a while loop for that till it reaches I. And the first thing which you have to do is increase it. So in this case, g of j refers to the character, and then we're using this as a key in the map. So initially, if it's not present, it will be taken as 0, which is the default value, and then you increment that and you move j to the left, which is basically decrementing it. And one thing you have to check here is, in case if the count of that character is already equal to n by 4. So in this case, you can't proceed further, so you exclude this character by incrementing j and you break out. Once you reach this stage, you just check if j is less than 0. If j is less than 0, it has reached this end and the condition hasn't been violated so far. So you can just return 0 because it's already steady. And in the other case, we initialize minimum length with j because you have one pointer j and I is at the start. And now we start pushing it from the other end. So in this case, we can only have a continue till j hasn't gone out of the string. In this case, we start from the ith pointer. So we access the character as g of I and we increase the count. So we have another while loop here, which is adjusting the j in order to make it steady again. And if you have to move j, you have to first make sure the j is less than n. And in this case, we keep repeating this process until the one which we've just incremented here is greater than n by 4, because that would be a violation. And inside of this, we do g of I count. This basically has to be decremented. Because we're moving j, we decrease that count and we keep pushing it to the right side. And once we've done with this, we can calculate the length. We have one pointer which is j on one side and we have I on the other end. The length would be the length of the string in between those two. So that's basically j minus I minus 1. And we have to update minimum length. Minimum length would basically be the minimum of min length and this newly calculated length. And after that we just move I to the next position and we keep repeating the process. So once we are out of this, we have the minimum length stored in min length, and we've done that. Let's try this. Yeah. So declaration. Yeah, go for the sample cases. Yeah, and as you can see, it has worked for all of the cases. To understand the time complexity of this problem, let's look at this string. So for this, you start with j pointer over here, and then you keep checking, and if you follow the procedure, you'll end up over here. And after that, you start from the left side, you take the I pointer, and you start checking. And each time you'll have to keep pushing j accordingly, and you realize that you'll have to come till the end for it to terminate. So the path traveled here is till here, which is nearly the start, and then you go back till the end. So that's basically n plus n, and so the complexity here would be 2n. If you hadn't used the two-pointer approach and you used some other approach like generating all the substrings and then replacing each of them and checking, that would be your n-square algorithm, which is much faster. So in this case, it's a linear time complexity, which is a quite efficient complexity for a lot of problems just like this one. That's it for today's video. If you have any doubts, leave it in the comments below, or you can head over to the Discord group. Thank you for watching.